Good morning. In the previous video, we have seen the analysis of cantilever beams, how to draw the shear force diagram and bend moment diagram. Now we are going to deal with simply supported beams. So in the analysis of cantilever beams, we are having only two steps. Directly we can go computation of shear force, and the second step, computation of bending moment. But remember, in the case of simply supported beams, the first step is always calculate the support reactions. A simply supported beam, it will be having two simple supports at A and B. You have to start the first step, find the support reactions. Without that, we cannot do the analysis. So how to find the support reactions? You have studied in your engineering mechanics classes. Go through the videos, discuss there. Now, I will explain it once again to make it easy. Reaction at A. Reaction at A, since there is only vertical load, there will be only vertical reaction. Let it mark it as RA. Since there is only vertical load, the reaction at B, I will mark it as RB. Assume both acting upwards. Now, sigma V is equal to 0. Sum of the vertical loads is equal to 0. RA and RB acting upwards. So, RA plus RB is equal to the total loads acting downwards, 3 plus 5. Or I can write RA plus RB minus 3 minus 5 is equal to 0. Effectively, RA plus RB is equal to total load 8. The first equation. Now, if you want to find RA first, take moment about B. Take moment about support B. So, next step is take moment about B. Of all the forces. So, RA, this is the direction of RA. If you take moment about B, it will produce clockwise moment. Clockwise. So, RA, it is acting at a distance 2 plus 2 plus 2, 6. RA into 6 clockwise. This 3 is acting down. If you take moment about B, it will produce anti-clockwise. So, minus 3 into distance is 4 minus this 5 is produce anti-clockwise moment. 5 into distance 2 is equal to 0. Or we'll get RA into 6 is equal to 3 into 4 plus 5 into 2. It works out to 12 plus 10, 3 into 4. This load is not 5, it is actually 6 in the question, sorry. It is 6. So here it is RA plus RB is equal to 3 plus 6, 9. And it is 6 into 2. So it is 24. RA is equal to 4 kilonewton. So, I'll repeat once again. RA plus RB is equal to 3 plus that load 6, 3 plus 6, 9. Taking moment about B, RA into 6 clockwise moment, 3 into 4 anti-clockwise moment, 6 into 2 anti-clockwise moment, so minus is equal to 0. From that we get RA is equal to 4. Now substitute this RA here. RA plus RB is 9. Therefore, RB is equal to 9 minus RA. 9 minus 4, 5 kilonewton. So this RA is 4 and this RB is 5. So that is the first step. You have to compute the support reactions correctly. Only then the remaining portions will be correct. So spend some time, double check it so that the support reactions are correct. That is the first step. Now, the second step is as usual. We have got all the forces now. We have got the reaction. We have got the external forces. So, shear force is nothing but algebraic sum of all the vertical forces. So, step 2, shear force calculation. What about the sign convention? For the shear force sign convention, what we have used is, if you consider a section, left of section, upward loads are taken as positive and right of section, downward loads are positive. If you consider a section XX, this is the sign convention for shear force. In the simply supported beam, it is easier for me. It is easy if you consider from the left side, because we have a reaction here RA. If I put a section like this in this portion AC, if I consider left of it, the total force acting to the left of it is there is only one force, 4 kilonewton. Consider portion AC. If you take any section on this portion AC, consider left of it, the vertical force acting is 4. According to the sign convention, left upward positive. So I can write here shear force at A. Shear force at A is 4. It is acting upwards, so it is plus 4. Consider point C. There is a vertical load acting at this point C. So you have to consider just to the left as well as right of it. Consider point C. Shear force at C. FC left. You move this section up to this point. What is the load? There is only this load. This 4 kilonewton acting upwards. So just to the left of C, there is only 4 kilonewton acting upwards. So it is positive. When you move to the right side of C, just to the right of C, if you consider the left of it, the 4 Newton acting upwards and 3 acting downwards. So FC right will be this 4 acting upwards and 3 acting downwards. So 4 minus 3, 1. Coming to point D, just to the left of it, total forces are 4 minus 3. So FD at D also there is a point load. So we have to write FD left. FD left is 4 upwards, 3 downwards. So 4 minus 3, 1. And FD right, just to the right of FD, when you consider just to the right of it, when you move to this side, the total loads are 4 upwards, 3 downwards, 6 downwards. So 4 minus 3 minus 6. So it is minus 5. And see here, just to the left of B, FB is 4 minus 3, 1 minus 6, we'll get minus 5. Just to the left of B, we'll get FB as minus 5. See, this reaction is 5. Right of section downwards is positive. This FB is acting upward. So we got the value negative. So we can check whether we are arriving at the reaction value. When you move from one side to the other, we are getting the right value. So I'll repeat. FA plus 4. FC left 4 minus. FC left also 4. FC right 4 minus 3. FD left 4 minus 3. FD right 4 minus 3 minus 6, and FB and FD are the same. Now let us draw the diagram. Once you draw the diagram, it will be more clear to you. Draw a baseline. Start from the first point FA4. So at the point A, 4 from the baseline, mark 4 units upwards. 4 units upwards. 4 kilonewton. Okay. FC left 4. So at this point also 4. So connect it horizontally. FC right is 1. So at this point C, you mark 1. You mark 1 from the baseline. So connect these 2 points. Now FD left is on. So here also you mark 1. Connect it. FD right is minus 5. So from the base you mark 5 units downwards. From here you mark 5 units downwards. Connect it. FD right is minus 5. FB is minus 5. So here also from here mark 5 downwards. This is the shear force diagram. See, we can, even without all these calculations, we can draw this. With the first step, I always calculate the support reaction. Draw a baseline. So here there is a vertical force 4 kN acting upwards. So from the baseline, a 4 kN corresponding to this 4 mark upwards. There is no load. So J's come straight. There is no load. Then there is a load 3 acting downwards. So come down by 3 units. This is 3 units. So 4 minus 3 will arrive at 1. There is no load. So you go straight. Then from this point, 6 acting downwards. So from 1, there will come down by 6 units. So 1 minus 6, you will come to minus 5. There is no load. You go straight. Then there is a vertical load 5. It's your reaction. So you go up by 5. So once you start from the baseline, you have to again come back to this point on the baseline. So your shear force diagram is correct if you get it like this. Okay, so this portion which is above the line, you mark it as positive, which is below the line, you mark it as negative. Then you hash the inside of the diagram. And we can see that wherever there is vertical load, the ordinate, the net ordinate will be that. Here the reaction 4, so there is 4. Here this vertical load 3, so this ordinate is 3. Here the load is 6, so this total ordinate is 6. This vertical ordinate. Here reaction is 5, so this vertical ordinate is 5. Where there is no load in that portion, the shear force diagram is parallel to the baseline. It is straight. It goes straight when there is no load. If you have this concept when you go to higher semesters, you can draw the shear force diagrams of any type of beams. Okay. Next, we have to pass on to the calculation of bending moment. Bending moment is also nothing but load into distance. Let us see that now. So, first step, we have calculated the support reactions. The second step, we have calculated the shear force and then down the shear force diagram. So here we have to write shear force diagram. Next step is computation of bending moment. So bending moment will start from this left end itself. The sign convention is left of section clockwise positive. This is positive. If you consider a section, left of the section clockwise positive or sagging positive. So simply supported end, remember, simply supported ends, bending moment is 0. This is a very important point to be remembered. That is at support A, load in the distance, bending moment will be 0, as well as at the support B, the load in the distance, that will be 0. Or if you compute from both sides, you can see, always remember a simply supported beam, the bending moment at the simple supports will be equal to 0. So I can easily write here, MA is 0, MB is 0 without any calculations. Even if you calculate, it will be 0. Now coming to point C. I come to point C. Here I am going to consider left of section. Left of C. Left of C, there is only one load, 4 kilonewton. Moment of that 4 kilonewton above this point is 4 into 2. It is numerically 8 kilonewton meter. What about the sign? 4 kilonewton is acting like this. So you place your thumb in this direction. Rotate it about C. Rotate it about C. So it comes. If you place your thumb like this and rotate it, it is going clockwise. Okay, this 4 into 2. It's going clockwise. So moment at C is equal to RA into 2. That is 4 into 2, 8 kilonewton meter. It is clockwise moment. So left of section clockwise is positive. Coming to next point D. Moment at D is equal to this RA, 4 into 4. That produces clockwise moment. So it is 4 into 4. And this load, this 3 kilonewton is acting like this. If you take moment above D, it will produce anti-clockwise. With thumb like this, it rotates the body, produces anti-clockwise moment. So minus 3 into 2. So 16 minus 12, 4 kilonewton meter. Now let's solve. We have got it RA into 4 minus 3 into 2. 4 into 4, 16. 16 minus 6 is 10 kilonewton. 16 minus 6 is 10 kilonewton meter. This we came from left end. We can do from either ends. So this is easy for you. If you want, I can explain once again from the right end. If you consider a section like this and consider right of section, there is load 5. If you take moment about D, that will also be 5 into 2, 10. This produces anti-clockwise. Right of section anti-clockwise moment is positive. That way also you will get the same 10. Okay, so in the case of simply supported beams, we will start from the left end and consider left of section. MA0, MC 4 into 2, 8. MD 4 into 4, 16. Minus 3 into 2, which is 10. MA and B 0. So now we can draw the diagram. Draw a baseline. I will extend this. Draw a baseline. Here all the values are positive values. MA 0, MB 0. So both these points are the baseline. Now MC 8 kilonewton meter. So from this point, this is point A, this is point B, this is point C, and this is point D. MC 8. So to some scale you mark 8 kilonewton meter. 8 units here. Connect it to the straight line. Then MD 10 at this point, which is 10. So connect it to the straight line. 10. MB 0. So this is the bending moment diagram. Hash the inside. This is 10 kilonewton meter. Right positive. Okay. Hope it is clear to you. So the entire bending moment diagram is above the line. The whole beam is subjected to a sagging moment. So next class I will deal with a problem where there will be combination of loads. This is only point load, so you illustrate it as a simple way. Next we will see simply supported beam with point load as well as uniformly distributed load. Thank you.